So in this video, we're going to take a look at just solving equations when we have to use substitution to help out. Sometimes we'll get equations that have more than one variable in them. There is no method that allows us to solve for two things at the same time without using something like a substitution method or getting rid of one of those variables. We can only solve for one at a time. So we'll take a look at some examples where we'll see that in action. So in our first case here, we have a triangle that has an area of 90 centimeters squared and a base of 20 centimeters. We want to find out the height of that triangle. So knowing that when we have a triangle with a base and a height, that we can find the area of that triangle by taking 1/2, multiplying it by the base and the height, and that's our formula. Now we have 1, 2, 3 letters in there. It's 3 variables. So we got to look back at our question, but we have values for 2 of them. We have 90 centimeters as the area, and we have a base of 20 centimeters. So we can substitute in 90 and 20 to get rid of 2 variables, leaving us just the h, and we can solve an equation with just one variable. So our area is 90. The 1/2 is still there. The base is 20. And that's multiplied by the height. And now we can go about solving this. We have 1/2 times 20 here. We can calculate that. That's 10. So 90 equals 10h. And now how do you get rid of that 10? Well, you divide both sides by 10. Multiply by 10 here, so the opposite is dividing. Divide both sides by 10. We're left with 9 equals h. That is our height. So sometimes when we're given, especially when we're working with formulas, we can just put the formula in, and then from that formula, we can substitute in the known values. And if we're left with one variable, which we were in this case, we're able to solve that, which we did. Another example using volume. Here we have a cylinder that has a volume of 785 centimeters cubed. If the height is 10 centimeters, what is the radius? So a cylinder, recall, has the 2 values we need, the radius and the height. And the formula for the volume of a cylinder is volume equals pi r squared h. So let's fill in those values that we know and see what variables we're left with. We know that the volume is 785. And we know the height is 10. But what about this pi? Let's leave that in there for right now. The height is 10. So there's pi. But remember, we know pi. Pi is 3.14. So we can actually put a value in for that as well. So we have now this value here. We have a 3.14 r squared times 10. So you may want to multiply this out. We have 3.14, and we can multiply that by 10, r squared times 10. So when we do that, we're going to get 31.4 equals r squared. And now I'm just going to move up here to continue that. Again, when you run out of space like this, you can use a nice arrow that points to where you're continuing that equation. It helps follow along rather than trying to jump all over the page and figure out what's going on. So I have this multiplied by 31.4 now. So I got to divide both sides by 31.4. So when I divide 31.4 here, those will get rid of each other, become 1r squared. And then when I have 785 divided by 31.4, I am left with 25. And that is r squared. And now I got r squared. To get rid of a square, I square root both sides. Square root of 25, square root of r squared. And I'm left with 5 equals r. There's my radius. So again, we're just taking the formula that we know, subbing in the values that we have, and then solving. And standard versions that we've done, we've just been given the radius and the height, and then the volume was already there. Here we're going everything backwards, or not backwards, but we're having to rearrange now and calculate these equations. All right, in this last one, we have Rick earns $15 an hour plus commission. If he makes $400 worth of commission, that should be 1 month. How many hours did he work if he is given a check for $1,600? So we can make his pay is equal to $15 an hour plus his commission. So he gets $15 an hour plus commission. So there's my rate. This is kind of set up like a linear equation. We know the pay, in this case, is $1,600. We're looking for the hours, and we know the commission is $400. So there we have a formula with one variable. We can now rearrange, calculate this, isolate that h. So to get rid of the plus 400, which I need to get rid of first, it's 1,600 minus 400, as we're going to subtract 400 from both sides. So we subtract 400 from both sides, we're left with 1,200 over here equals 15h. And then to get rid of the 15 with the h, we divide by 15. And we divide both sides by 15, and we will get, I believe, 80. Yes, 80. 80 equals h. So he's worked 80 hours that month. So when you're going about solving equations and you have multiple variables, here we had 3 variables, here we had 3 variables, up here we had 3 variables. In the case when you have more than one variable, you'll need to do some sort of substitution or replacement of one of those variables so that we get it down just to the one variable, like we did here, like we did here, like we did down here. Okay, so we can't solve multiple variables, so we want to get it down to one variable. There are cases where you would rearrange an equation with multiple variables, but when you want to solve it, you do need to get it down to the one variable. All right, so that is substituting into equations to solve them. This is the last of the content that we need to cover for this year. So if you've made it this far, you are done. Good job.